Okay, so with this one right here, this is just kind of a continuation of that other stuff. Here we're just talking about how we could place things. So let's just say, as an example, we just use a square here. So I could have, this is 0, 0, this is 0, whatever, this would be whatever, 0. So like you could put your square right here. So what's nice, this is just like how you put the quadrilateral into the coordinate plane. So what's nice about this one is you're using a 0. So you're using 0. So there's not as much stuff. This will end up being 0. Not as many things as you need that you need to label or figure out ordered pairs for. Like if I put the square here, this would be kind of a pain because I'd have to call this something like, I don't know, A. So this would be maybe A0. This is going to have to be B0. Sorry, that's parentheses right there. This is going to have to be A and then C, and this is going to have to be B and C. So I'm using more letters than I'd have to use over here. Another thing you could do with a square or shape is maybe it makes sense to put the middle of it at the origin. Maybe it makes sense to turn it this way and have the middle still at the origin. So sometimes there's a couple different ways, but they can all kind of work. All right, so let's look at some examples here. So, and these ones right here, they're kind of giving us these hints too. So rect is a rectangle with height A. So I know that this distance right here is A and length 2B. The y-axis bisects it, so it splits it in half. So this is 0, 0. So then if this length is 2B, this must be B0. And this over here must be negative B0, because I need to get that distance there to be 2B. Well, if this is BMAX, then C is also has an x of B, but now that height was A, so A would go there. And if this was negative B over there, then this is negative B, and this also has that height of A, okay? All right, height. So IE is equal to 2A. So this distance, so again, this distance from here to here is 2A. This distance right here is B. So if this, and this is 0, 0, so this is going to have to be negative B0, so make that distance there. And then this distance right here is C. So this is going to have to be C0. This right here, so this distance is 2A. I know right here, the way that this kite's put, that this x is 0. So if this is A, I'll just make this one negative A. And this one up here would be 0 and positive A. Okay, so they're kind of giving me some hints here. This one says, find the coordinates of the intersections of the diagonals. So the intersection, you're just finding the midpoint of these diagonals. So one way I could do it is I could use this point and this point. So let's find the midpoint of OB. So I would take 2A plus 2B plus 0 over 2, 2C plus 0 over 2. So that'll just end up simplifying to A plus B, comma C. If I check, so if I do the midpoint of AC, this should be MD, midpoint of AC, I would do 2A plus 2B over 2, and then I'd have 0 plus 2C over 2. So then again, I'd get A plus B, C, okay? All right, here. So in this one right here, so another thing kind of back here, what you'll notice with that last problem that we just did before I go over here to this one. When you're talking about placing things, if you noticed here, it was really nice that I had these 2's here. And the reason why it was nice is because when I was adding them up, I knew I was going to have to divide by 2, so then I could cancel that. So it's nice, if you think you're going to have to use the midpoint formula at some point, it's nice to kind of put some 2's in front of things. Again, we're just kind of arbitrarily picking points. So plan a proof of the trapezoid mid-segment theorem. Okay, so So I'm going to have to find the mid segment here. So I'm going to start with one of my points at a vertex. This is a terrible trapezoid. So this will be A, B, C, D. So I'm going around that way. Here's E, here's F. Okay, so I'm going to put A at 0, 0. I'm going to put B at 2A, 0. Again, I know I'm going to have to find that midpoint there. So if I put that 2 there, it'll just make it a little bit easier for me to do it. For C, well, let's do this one here. So for D, I haven't defined anything here. So I'll just call this 2B, 2C. Could I call it B, C? Sure. But again, if I know I'm going to use the midpoint formula, why not just put a 2 in front of it so it's easier to divide? This one right here, again, same thing right here. I don't know what that x value is, but I do know what the y value is because it's on the same height there. So this is going to be 2D, 2C. Okay? So since I need to calculate midpoints, I'm going to use ordered pairs with that 2 in them, okay? So if I was proving the trapezoid midsegment theorem, so my plan would be to find the coordinates of E and F. So I'm going to have to find out what those are. I'm going to have to find the slopes. Because remember, the trapezoid midsegment theorem says all these lines are parallel, so I'm going to have to find the slope of DC, the slope of EF, and the slope of AB, and show they're all the same. If they're all the same, then they are parallel, okay? The other thing the midsegment theorem says is I want to show that EF is equal to half of AB plus DC. So I need to find the lengths of EF, AB, and DC to show this works, okay? All right, this one, let's see here, I can pick out a couple of these to maybe do with you. Oh, and before I even pick out some to do with you, just some suggestions here for your placement. Place at least one side on an axis. So like you have one of the vertices on the origin, or you could try to center it at the origin, kind of like what I talked about in the first page there. If you're going to be finding the midpoint, use that 2, just put that 2 in front of them. Instead of using like A, comma B, you use 2A, comma 2B. That just kind of makes it easier when you're dividing it by 2. If anything has to be perpendicular, so if you want to show, you know, that if you're putting a rhombus out there and you want to show the diagonals are perpendicular, it's kind of nice if you put the diagonals on the lines, the horizontal and vertical lines, because that really helps you ensure that you get a 90-degree angle, else you're kind of eyeballing it and you're just kind of gonna mess it up probably, okay? All right, so let me look here at 6, 8, see which ones would be good to do with you. Looking at the wrong page. Okay, so like here, so you had to do number 9. So squared centered at the origin with side length B. So what I did for this one, so the side length is B, so I, between the two of them, I can only, you know, this distance has to be B between all of them. So I just made this one like B over 2, B over 2. And then this one down here, the x is still B over 2, because then if I had this, So b over 2 plus another b over 2 is just going to give me 2b over 2. So then I'm going to have the distance there of b. Okay, so w I have is b over 2, b over 2. Z still has the same x coordinate, so it's b over 2. But then I use that negative b over 2. Then this, I'm just going to go over in this direction, negative b over 2. So this is negative b over 2 within positive b over 2. This one is negative, negative, so both negative b over 2. Okay, so that's what I did for S, or for 8, sorry. For 13. Okay, 13 says, the diagram below shows parallelogram. Without using the distance formula, determine whether the parallelogram is a rhombus. How do you know? So again, in the rhombus, the diagonals are perpendicular. So just find the slopes there. So I found the slope of AC. So I got 2a over negative 2a, which is negative 1. Then I found the slope of BD. So I got 2b over 2b, which is 1. So those are opposite reciprocals, so the diagonals. So yes, it's a rhombus. The diagonals are perpendicular. Let's see here. All right, 20. Let's do 20, and then that's it. So 20 says, draw a square whose diagonals have a length of 2b that lie on the x and y axes. So I want my diagonals to be on the x and y axes. So I'm going to draw it. I drew it this way. I just think it's a little bit easier. You'll see why I drew it. So these would be my diagonals on the x and y axes there. So then when I have to give the coordinates of the square, it's a little bit easier. Like if I would have made this look like this, so that actually my diagonal still wouldn't be on there, right? So I don't think you could do it any other way. It says answers may vary, but I don't know what else you could do. All right, B. Give the coordinates of the vertices of squares. So again, this one right here, B and D, you'll know that the y coordinate is 0. A and C, the x coordinate is 0. So, but you know the distance of the diagonals has to be 2b, so it has to be b in this direction, b in this direction. So A is at 0b, B is at b0. Down here, I'm at 0, negative b. Over here, I'm at negative b0. For C, compute the length of a side of a square. So again, if you just want to find the side, use the distance formula. So I did 0 minus b squared would be b squared. B minus 0 squared would be b squared. So I got 2b squared, so I got b squared to b. Find the slopes of two adjacent sides of the square. I found the slopes of a bunch of them, but the slope of AB is just negative 1. The slope of BC is 1. Then it says here, do the slopes show that the sides are perpendicular? So yeah, because these slopes are opposite reciprocals, yes, it does show that they're perpendicular. Okay, that is that.